Hi friends, see today we will be starting the second part of the wave optics. In first part we have completed wave optics up to the fringe width derivation, okay, for dark and black bands, okay, bright bands, dark and bright bands. So in part 2 of wave optics, already in part 1 we derived for bright, that is Y bright, that is for nth n lambda d by d, and for dark 2n minus 1 into lambda d by 2d. These are the things we have derived, okay. And you know, if you substitute for first one, n is equal to 1, you will get lambda d by d. We substitute n is equal to 2 lambda d by d, 3 lambda d by d, so on. And this is nth bright. In the same way for dark, n is equal to 1 lambda d by 2d, n is equal to the 4 minus 1, 3 lambda d by 2d, so on and so forth. So these are the things we obtained in the part 1, that is for bright and dark bands. And now in this class we will be dealing about, okay, what is fringe width? What is fringe width? Fringe width is nothing but the thickness of the band, bright or dark band, okay. Generally fringe width is given by in this fashion, okay, and this is given by lambda d by d. The fringe width formula is given by lambda capital D by d. So this is the formula obtained for distance between, that is distance between any two consecutive bright or dark bands formed on the screen. And the other entity, suppose in yesterday's class, see I will show you. In previous class, that is in part 1, we have discussed about the derivation, that is we have obtained some, see this is YD experiment, SC experiment. In this you have taken two slits, S1, S2. The distance between the two slits is taken as D, and this is the screen, of course. This is screen, and the distance is maintained as capital D between the screen and the slits. And we know capital D is very much greater than small d, and lambda is what? Very much less than small d. Okay, because this is in nanometer, this is in millimeters. And this is of course central bright. Okay. And in this case what we observed is, so here this is central band and this is the point P, okay, from S1 source. This is S2 source and this is the middle portion. It is making an angle theta, and if that is angle theta, this is also theta. This is 90 minus theta, total angle 90, and you have dropped a perpendicular on this one named as M, okay, and this is of course finally theta. And this delta x, that is S1M, which is called as delta x, which is the path difference, because S1P is greater than S2P is greater than S1P. Geometrically you can see this one is greater, therefore this is the difference. Into difference delta x. This difference allows the opposite by hypotenuse. Opposite by hypotenuse, that is nothing but sin theta. So this delta x is d sin theta, we got it. Okay. So this is the path reference between the two waves. Now what we got different equations for nth bright, nth dark. Okay. That means this is central one. That means here delta x is equal to 0. So ఇక్కడ delta x అంటే ఇక్కడ మనకి central bright form అయింది. తర్వాత again bright తర్వాత dark, మళ్ళీ ఇక్కడ dark, first dark, first dark, that again bright, first bright, again bright, first bright, again second dark, second bright, third dark, third bright. In the same way, first bright, dark bright, again dark, second dark, again second bright. So like this on both sides of the central band, on this side and this side, we will be getting dark and bright bands successfully. That means if you see the difference between any two successive bright bands, for example, first bright ఎంత వచ్చింది మనకి, first bright we got as lambda d by d. అలాగే second bright ఎంత వచ్చింది, we got the distance as 2 lambda d by d. Now what is the difference, separation? Difference is second bright minus first bright. So 2 lambda d by d minus lambda d by d. See LCM anta d. 2 lambda d minus lambda d. What is the value here? Lambda d by d. See, that means distance between any two successive bright bands. Distance between any two successive bright bands is the width of the dark band. Is the width of the dark band or dark fringe. In the same way, distance between any two consecutive dark bands. Dark band, for example, see, this is first one, lambda d by 2d. Second one, 3 lambda d by 2d. So find the distance, separation, second dark minus first dark. That is 3 lambda d by 2d minus lambda d by 2d. So what is LCM? 2d. 3 lambda d minus lambda, that is 2 lambda d by 2d. So what is the answer? Lambda capital D by d. This is the difference between two successive dark bands, and which is equal to the width of the bright band. Width of the bright band. So this is how you will explain the width of the bright band and width of the dark band. Distance between two successive bright is equal to lambda d by d. This and this are same, and this is equal to width of the dark band. Distance between two successive dark bands is equal to same value, and this is equal to width of the bright band. Please, okay? Please copy this one. These are very, very important. Now we will do a small numerical in this one. ఒక చిన్న న్యూమరికల్ ప్రాబ్లం మనం చేద్దాం. Copy? Right. Now, see here. Small numerical I am giving for you. That is, for example, distance between the slits D is given as say 1 millimeter, that is equal to M case lo marcha 10 power minus 3 meters, and a capital D screen distance is given as 0.6 meters. Let us assume capital D. Lambda wavelength is given as 4000 angstroms, that is equal to 4000 into 10 power minus 10 meters, because since 1 angstrom is equal to 10 power minus 10 meters. 10 power minus 8 centimeters or 10 power minus 10 meters, all are converting into M case. Okay, now what is saying is the question, 5th maximum and 10th minimum. See, 5th maximum, 5th maximum and 10th minimum. Maximum means bright band, minimum means dark band. Okay, so these are on the same side, it seems, from the central band. These two are formed on the same side of the central band. Central, okay, వైపు అది ఇదే నవ్వచ్చు ఇటే నవ్వచ్చు. So he is asking you what is the distance between these two. Same side form అయినప్పుడు you have to subtract, opposite side form అయినప్పుడు you have to add up the distance. So here first of all you will find the 5th maximum. What is the general formula? nth bright formula ఏంటి? n lambda d by d. So what is the, we want 5th one. So we want 5th and 10th. 5th bright is equal to, put 5 here. 5 lambda d by d. Got it? 10th minimum. What is the minimum for nth dark? 2n minus 1 into lambda d by 2d. So here put value 10. So y10 dark is equal to put 10. 10 to the 20. N plus 10 by 10 to the 20 minus 1. 19 lambda d by 2d equation 2. So distance between these two and enti separation, that is minus this one. That is, I'll write it here, y10 dark minus y5 bright. That is 19 lambda d by 2d minus 5 lambda d by d. So LCM is 2d on the top one time, that is 19 lambda d minus lambda 2 times 10 lambda d, because d kada, d into 2 10. Nth మిగిలింది మనకి 9 lambda d by 2d. So this is the distance between the two, that is 5th maximum and 10th minimum on the same side. Now we are getting the values. ఎంత వచ్చింది మనకి value? 9 lambda d by d వచ్చింది. Now substitute the values here already given. Values ఇచ్చారు కదా, values substitute చేసేద్దాం. See here, values are given here. What is the distance between separation? 9 lambda d by 2d వచ్చింది కాబట్టి 9 into lambda, what is the wavelength given? 4000 into 10 power minus 10 meters into d. All I am putting in MKS d by 2 into small d, 10 power minus 3. So 2 ones are 2.3 are. Okay. So here we will multiply 9 4s are 36 into 3. That point I will drop here, 10 to the down. Okay na? So then 9 4s are 36 into 3. 9 4s are 36 into 3 into 10 cube and 10 power minus 10. 10 power minus 7. Minus 10 plus 3. Minus 7. And down denominator already maniki minus 3 plus 1. Minus 2. 3 6 are 18, 8, 1, 3 are 9, 10. 108 into, take 10 power minus to the top, plus 2. Plus 2 minus 7, minus 5. So, how much I got? 108 into 10 power minus 5. So, I will try to put decimal here after 2. Divide by 100, multiply to 100. So, 1.08 into 10 power, multiply and divide chesam kabatti this square minus 3. So what is the distance? 1.08 in 10 power minus 3 meters. And we know what is 1 millimeter. 1 millimeter is equal to 10 power minus 3 meters. So if you write it in millimeter, it is what? This is equal to what? 1.08 millimeters. Okay na? 1 point, because 1 millimeter is equal to 10 power minus 3 meters. So 10 power minus 3 into this, therefore 1.08 millimeter distance between the 5th maximum and 10. So this is how you have to solve the problems. Clear? So just for the practice purpose I have given on numerical, please practice such type of problems in your books to understand in a better manner. Okay, clear? Right. Now let us go to the next item. Okay, that is next one in our version is in this chapter, how to calculate number of maximum bright bands and number of minimum dark bands. Okay, on the either side of the central. For example, you can see in this figure, this is central band. You can see it getting first dark, first bright, second, first bright, dark, bright, dark. So like that you are getting so many bands. So many bands, bright and dark on this side and also on this side. Now what is the question is, we have to calculate how many bright bands and dark bands are formed on the either side, total, on the either side, total. So we'll try to calculate, we'll get a formula for this one. See, already yesterday we derived one equation. ఏంటది చూడండి. This, what is this distance, ఇదంతా అంటే the displacement delta x. This delta x path difference we got as d sin theta kada. Path reference we got as S1 and S2 sources to this point P. We got d sin theta. And please make a note, what is the d sin theta equal to? Okay. For example, for first bright it is equal to what? Path reference. తెలుసు కదా, lambda, 2 lambda, 3 lambda, n lambda bright ki. For bright bands. అలాగే డార్క్ కి lambda by 2, 3 lambda by 2, 5 lambda by 2, 2n minus 1 into lambda by 2. ఇది డార్క్ బ్యాండ్స్ కి. సో వాట్ డస్ ఇట్ మీన్? ఫర్ ఎగ్జాంపుల్ మనకు బ్రైట్ కావాలి, అప్పుడు ఏం చేస్తాం? d sin theta ఫస్ట్ బ్రైట్ అయితే లాంబ్డా, nth అయితే ఎంత అవుతుంది? n into lambda. Path reference. Okay, because we have to calculate how many bright bands are formed from the central band, this side and this side, including this one central band. Okay, so ఏమైంది ఇక్కడ నుంచి జాగ్రత్త చూడండి. From this I am getting as sin theta is equal to n lambda by d. Clear? Sin theta is equal to n lambda by d. But you can see what is the maximum value of sin theta. See, sin 90 is equal to 1. So 1 కన్నా ఎక్కువ ఉండకూడదు యాంగిల్. అంటే అర్థం ఏంటి ఇక్కడ? theta cannot be greater than 1. ఓకేనా? can 1 అంటే అర్థం ఏంటి ఇక్కడ? అది మీన్ sin 90. ఈ వాట్ ఎవర్ వాల్యూ ఇట్ కెనాట్ బి గ్రేటర్ దెన్ 1 బికాస్ మ్యాక్సిమం వాల్యూ ఇస్ 1, మినిమం ఇస్ 0 సైన్. అంటే అర్థం ఏంటి ఇక్కడ? sin theta cannot be greater than 1 value. In other words, because ఎందుకు ట్రిగ్నోమెట్రీలో మనకి sin minimum value 0, maximum 90. సో ఇక్కడ ఎంత అయితే sin theta ఉంది ఇక్కడ వాల్యూ, ఓకే, cannot be greater than 1. సో వాట్ హ్యాపెన్స్? పుట్ ద వాల్యూ హియర్. sin theta అంటే ఇక్కడ ఏంటి? n lambda by d cannot be greater than 1, or n lambda cannot be greater than d, or n cannot be greater than d by n, d by lambda, d by lambda. Please, I am trying to tell you how many bands, d by lambda. So in form d by lambda on one side, and what about other side? ఇంకోటి ఫామ్ అవుతుంది అంటే 2 times. ఓకే, సో దట్ ఈస్ ఈక్వల్ టు 2d by lambda. And what about the central bright? అది కూడా ఉంది కదా, +1. క్లియర్? సో టోటల్గా ఎన్ని బ్రైట్స్ ఫామ్ అయ్యి బ్రైట్ బ్యాండ్స్ చూడండి. నెంబర్ ఆఫ్ బ్రైట్ బ్యాండ్స్ ఫార్మ్డ్ ఆన్ the either side of the central bright, including central bright, this side and this side, that is 2 times 2d by lambda plus 1. And please make a note, this value you have to take, you have to take integer value. What is meaning of integer? Real value and points. For example, 2d by lambda plus 1 you got, for example, 3.4. Then what you have to take? You have to take it as 3. You got 3.9. You have to take it as 3 only. 3.5. You have to take it as 3 only. So this is the integer value. You should not take point value. Okay? The 2d by lambda is wavelength will be given. D distance between the slits will be given. So after adding this one, suppose if you are getting in decimals, you have to take the integer value. Okay na? Like 3.4 is the 3, 3.9 is the 3. Clear? So how many bands are formed? Finally, 2d by lambda plus 1 on both sides, including central band. Clear? Now we will calculate for dark. Bands. Okay na? Clear? Clear? Any doubts? So I'll write it in this side. ఈ పక్కన రాస్తాను మీకోసం. Here. See. So finally, number of ఎన్ని వచ్చాయి మనకి 2d by lambda plus 1. This is number of bright bands formed on either side, including central band. Now we'll go for dark. ఇదే విధంగా dark ఎన్ని ఫామ్ అవుతుంది చూద్దాం. Dark. So what is the formula for dark? Once again, see, d sin theta is equal to, what is the formula for nth one? 2n minus 1 into lambda by 2. So ikkadi nunchi what is sin theta? 2n minus 1 into lambda by 2d. d kindaku vachestundi. Same again, ikkada enti angle theta cannot be greater than 1. Theta ante adi sin theta. Sin theta, because sin maximum value is 1 kada, minimum is 0. So sin theta cannot be greater than 1. So put it here, 2n minus 1 into lambda by 2d cannot be greater than sin theta. Okay, because sin theta is equal to kada. So this cannot be greater than 1 from this equation. Leda 2n minus 1 into lambda cannot be greater than, take 2d this side, 2d, or 2n minus 1 cannot be greater than 2d by lambda, or 2n cannot be greater than 2d by lambda, take minus 1 to this side, plus 1, or n cannot be greater than, divide with 2, that is 2d by lambda plus 1 divided by 2, that is equal to d, that is d by, when you divide you will get it as, very very important formulas in numericals for MSET and NEET. When you divide by 2, d by lambda, 2 to divide plus 1 by 2. This is one side, this side. What about the other side? Include good form ante 2 times. This plus again inkoti d by lambda plus 1 by 2. So what happened? 2 times. So 2 into d by lambda plus half. And central bright is bright kaadu, dark kaadu kabatti you should not add for here. So this many identivi number of dark bands formed on the either side. And once again this value, integer value, please, again integer value. For example, ఇది క్యాల్కులేషన్ చేస్తారు మీరు, d by lambda plus 1 by 2 7.9 వచ్చింది లోపల బ్రాకెట్ లోపల, ఈ బయట ఇంటూ 2 ఉంది. యూ షుడ్ నాట్ మల్టిప్లై విత్ 2. 2 9s are 18, 2 7s are 14, 15 అలా మల్టిప్లై చేయకూడదు. ముందు దీని ఇంటిజర్ వాల్యూ తీసుకోండి. ఫస్ట్ టేక్ ది ఇంటిజర్ వాల్యూ. 7.9 ఇంటిజర్, డోంట్ టేక్ 8, 7 ఓన్లీ. 7.8 వస్తే 7, 7.5 7 only. Then you multiply with these two. For example, in this case 7.97, 7 to the 14. So 14. How many number of darks are formed on either side? 14. In this fashion you have to take in the numericals. So this entire value you have to take integer value, not after multiplying. Integer and then you multiply with this one. In the same way here also, this entire value is taken as integer value. Clear? So these are very very important formulas for solving numericals in the examinations in MSET and NEET. Please practice well regarding these formulas. Clear? Right, now let us go further in this chapter. Clear? Clear? So what you got finally? D by lambda, 2d, 2 times by lambda plus 1. Okay, for bright. And next one is d by lambda plus 1 by 2, 2 times. So these are two formulas. These are number of bright bands formed on either side including central band. And this value is integer value to take. 2 times 2d by lambda plus 1. Again d by lambda plus 1 by 2 times, excluding central band. This is the number of dark bands formed. Okay, on the either side. సో ఈ ఫార్ములాస్ బాగా గుర్తుపెట్టుకున్నట్టుగైతే మీకు న్యూమరికల్స్ ఈజీగా చేయొచ్చు. లెట్ us go further now. Clear? Right? Okay. Now, after completing successfully all these things, now let us go to the next one, that is how to calculate, that is how to get shift value when suppose glass slab is introduced between one of the slit. For example, ఇదే figure తీసుకుందాం. Same figure I'll take. Now the question is ఏంటంటే suppose a glass slab of thickness T is introduced between any one slit. ఇది slit 1 కదా, this is slit 1, okay, slit 1. This slit suppose is having thickness T and refractive index some mu, or this slit is or this glass slab is kept in slit 2. Slit 1 గానీ slit 2 గానీ ఎక్కడైనా అడ్డంగా పెడితే, if you put glass slab as an obstruction, then what will be the shift? Okay, glass slab of thickness T is kept at either slit S1 or S2. What will be the shift? What is shift here? That means ఈ central band ఎక్కడికి మారిపోతుంది. Before central band is here, because before the central band is here. So when you introduce a glass slab, how the shift will be changing? Okay, so for that I'll explain you by giving a small example. For example, two light waves తీసుకుందాం. This is one light wave, this is another. This is one light wave, this is second light wave. Suppose this is, we'll name some letter A, AB, CD. This is AB is one light wave, CD is another light wave. For example, ఇక్కడ నేను గ్లాస్ స్లాబ్ పెట్టాను అనుకున్నాను దానికి. Let the thickness be small t. Let the thickness of the glass slab be small t. Here nothing is there, only air column. Just to understand, I am drawing a line like this, balancing line. Here it is air column, nothing is there, air column. That means the wave is continuously going, nothing obstruction is there, only obstruction for this one I have kept. Now for example, ఈ glass slab, for example, the speed in the glass slab be V and mu be the refractive index. Let mu be the refractive index of the glass slab and V be the velocity, speed in this glass slab. Now this wave is traveling, this wave is also traveling. Let us try to calculate in delta t time. In delta t time, these two waves, AB wave and CD wave, how much distance it will be traveled in delta t time. Okay, so first we will see for this one. So already refractive index and mu and V. So for this, what is mu? Refractive index is given by speed of light in air by speed of light in denser medium. Equation 1. So mu is equal to C by V. And this wave has to travel this thickness. Glass slab addu undi. It daatukunte vellali. So what happens? It takes little time. So let the time be delta t for both the waves, of course. So delta t time lo enta travel avutundi the distance? This distance it has to travel. Distance is equal to speed into time. So what is speed? Speed, see, ఈ distance travel అవ్వాలండి, t travel అవ్వాలి ఇది. So this distance, చూడండి ఒకసారి, distance is equal to speed into delta t for this wave. CD wave కి ఈ distance travel అవ్వాలి delta t టైంలో, ఓకే, లేదా t by v is equal to delta T. Okay. Now from this equation, what is V? So what is V here? V is equal to C by mu. Put it here. T by V plus C by mu. That is equal to delta T. Leda T into mu పైకి వెళ్ళిపోతుంది by C is equal to delta T. So this is the time for second wave. In the same way, ఈ వేవ్ పరిస్థితి ఏంటి? దీనికి ఏం అడ్డు లేదు. అప్పుడు ఏమవుతుంది? ఇది కొంచెం ఫాస్ట్గా వెళ్ళిపోతుంది బికాస్ ద వెలాసిటీ ఆఫ్ లైట్ ఇన్ ఎయిర్ ఈజ్ మోర్. సో ఇది కొంచెం అడ్వాన్స్ అవుతుంది అప్ టు సమ్వేర్ ఓవర్ సైడ్ బి డాష్. దీనికన్నా బికాస్ దీనికి అడ్డం పెట్టాం గ్లాస్ ల్యాబ్. సో దిస్ వే విల్ ట్రావెల్ అడ్వాన్స్ లిటిల్ ఫాస్టర్. So for this one, what is the distance? For this wave, distance is equal to travel. Distance is equal to speed. C into time, same time, delta T. But what is delta T here? T mu by C. Mu T. Therefore, AB wave కొంచెం అడ్వాన్స్ అయిపోతుంది because there is no obstruction for AB wave. It will travel mu T. ఈ డిస్టెన్స్ ఎంత ఇది? ఈ మొత్తం డిస్టెన్స్ చూడండి, ఇది ట్రావెల్ అవుతుంది ఎంత? mu T. And this one only T. So what is the difference, path reference between this wave and this wave? Delta x. ఎంత డిఫరెన్స్ ఉంది? mu T minus T. See here. mu T minus T is equal to delta x. లేదా T into mu minus 1 is equal to delta x. So this is the path difference between the two waves when any obstruction like glass slab, either you keep it at S1 slit or S2 slit. అర్థమవుతుంది మీకు? ఈ స్లిట్స్ దగ్గర ఇక్కడ కానీ అబ్స్ట్రక్షన్ పెడితే what will be the shift? And I mean shift in the sense, what is the path reference? T into mu minus 1 will be the path reference. Now we'll utilize this formula in this case and we'll try to derive the shift, please. Clear? Right. అర్థమైందా? So that is why I have derived this equation to understand better manner, and that equation will be using in the next derivations. అర్థమవుతుంది మీకు? So what is the path reference? Delta x is equal to T into mu minus 1. We'll utilize this formula. Thickness of the glass slab into refractive index into the in that glass slab minus 1. Now that is the path reference between the two waves. That చూడండి ఒకసారి ఈ ఫిగర్ మళ్ళీ నేను గీస్తాను for a better understanding. See here. Now what I am doing is, these are the two slits. This is the central band. Okay. Now this is first slit. Now here I am putting obstruction, slab, mu refractive index and T thickness in the first slit. Okay na? Now suppose the light is coming, first light ray, and this is second light ray. Now observe carefully this figure. S1P is not equal to S2P. S1P geometrically, this is P for example. Geometrically S1P distance is not equal. Why? Because this one is traveling more distance. S1P has to travel more distance because of the obstruction. Enta this much extra. Adotha point. Ippudu ee రెండిట్ల మధ్య difference delta x is not 0 now. Now in this case delta x is not 0 because S1P is not equal to S2P because glass slab is kept between the first slit, not in the second slit. So delta x ఇక్కడ 0 అవ్వదు. సో ఒకవేళ 0 అవ్వలేదంటే సెంట్రల్ బ్యాండ్ ఇక్కడ లేదు, ఇట్ హెస్ షిఫ్టెడ్ టు సమ్వేర్ either top or bottom. We don't know, we have to find out. The central band is shifted either to the top or this side. We have to find out. అది ఎలా ఫైండ్ చేయాలి? ఫర్ ఎగ్జాంపుల్ if you assume, see, for example, if you assume ఇఫ్ యూ అస్యూమ్ హియర్ ఇక్కడ షిఫ్ట్ అయింది అనుకుందాం ఈ పాయింట్ని పి ఇక్కడికి చెక్ చేద్దాం. ఇక్కడ షిఫ్ట్ అయితే సపోజ్ ఇది ట్రావెల్ అయింది ఇక్కడికి లైట్, ఇది ట్రావెల్ అయినప్పుడు ఏమవుతుంది చూడండి, దీనికి తక్కువ డిస్టెన్స్ ఉంటుంది చూడండి, S2 వేవ్ తక్కువ డిస్టెన్స్ ఉంటుంది. S1 ఏమవుతుంది, ఆల్రెడీ గ్లాస్ స్లాబ్ ఉంది, ఇది ఆల్రెడీ డిస్టెన్స్ ఎక్స్ట్రా ప్లస్ దిస్ ఎక్స్ట్రా. సో సెంట్రల్ బ్యాండ్ వచ్చే అవకాశం లేదు ఇక్కడ. ఇక్కడ చూద్దాం, విల్ చెక్ అవుట్ టు ద టాప్. లెట్ us చెక్ అవుట్ టు ద టాప్. పైన చెక్ చేద్దాం పీని. సపోజ్ ఇఫ్ దిస్ బ్యాండ్ హ్యావ్ షిఫ్టెడ్ టు హియర్, let this distance be some y from the central band position. ఇప్పుడు ఇక్కడ షిఫ్ట్ చేస్తే జాగ్రత్త చూడండి, ఈ లైట్ రే, this is the light ray. So now this is what distance, S2p. And what about S1? This is S1. Now observe carefully. Here S2 is greater, of course, geometrically. S2 is greater than S1p. And the same way, if you drop a perpendicular as usual, and of course the central one, angle making theta, and this is again theta, and this is 90 minus theta, and this is again theta. ఇప్పుడు మీరు జాగ్రత్త అబ్జర్వ్ చేస్తే ఇక్కడ, when I drop perpendicular here, what is this distance? Before we found out delta x, d sin theta. What was this distance? Because now geometrically S1p is equal to S2p. Because this one d sin theta, అంటే ఇప్పుడు మనకి ఇది ఏదైతే d sin theta ఉందో డిఫరెన్స్ S2pకి, that d sin theta if you equate to this one, then S1p is equal to S2p అవుతుంది. If the point P if you consider here, what you have to do to get here the central band? These two, this whatever d sin theta should be equal to this one, t into mu minus 1. Because what is our concept mainly? S1p minus S2p should be equal to 0. అదవుతుంది మీకు, S1p minus S2p should be equal to 0. So whatever extra distance has travelled by S2p, d sin theta, if you equal to the extra distance of S1p, then central band will be here. Then the delta x will be 0. So therefore, d sin theta is equal to t into mu minus 1. Clear? And from this, what is sin theta? T into mu minus 1 by d. And as usual, we know this is y and this is d. And what is tan theta from here? Tan theta ఎంత అవుతుంది? Y by d. And as I told you, d is very larger. Capital D is very larger than small d. So almost what happens? The angles are very small. Sin theta is almost equal to tan theta. Therefore, equate both. Equation 1, equation 2. So t into mu minus 1 by d is equal to y by capital D, or t into capital D into mu minus 1 by d is equal to y. So that y, this is the distance. Central band is shifted to the top because of the obstruction of the glass slab. Glass slab అడ్డు పెట్టడం వల్ల స్లిట్ ఉన్న దగ్గర సెంట్రల్ బ్యాండ్ ఎక్కడికి వెళ్ళిపోయింది, ఇంత డిస్టెన్స్కి వెళ్ళిపోయింది. Now this is the central band. Td into mu minus 1 by d. Clear? Please note down. Very, very important. Now we will calculate first bright, second bright, third bright, fourth bright, nth bright. Okay, now start chadama. Please copy this one. Right. Now the central band has gone to this place. ఇక్కడికి వచ్చింది సెంట్రల్ బ్యాండ్. ఇక్కడ ఎంత దూరంలోని, ఫ్రమ్ ద సెంటర్ ఇట్ హెస్ గాన్ టు దిస్ మచ్ డిస్టెన్స్. నౌ వాట్ ఈస్ ద ఫస్ట్ బ్రైట్? వెరీ ఈజీ. నౌ ఆల్రెడీ యూ నో ద ఫార్ములా. వాట్ ఈస్ ద nth వన్? n lambda d by d కదా. సో ఫస్ట్ ఇది కావాలని ఏం చేయాలి, ఇక్కడ 1 పెట్టండి. సో lambda d by d ప్లస్ దిస్ వాల్యూ. because already the central band is not here, it has shifted to this place. So అప్పుడు ఎక్కడ ఎంత వస్తుంది, lambda d by d plus t capital D mu minus 1 by d. This is the first bright. Same way second bright, 2 lambda d by d plus t capital D mu minus 1 by d. అలాగే థర్డ్ బ్రైట్ 3 lambda d by d plus td into mu minus 1 by d. అలాగే nth బ్రైట్ n lambda d by d plus td into mu minus 1 by d. So these are the formulas you have to remember well when glass slab is introduced between either here or here. Clear? Now we'll calculate for dark bands. Now the subject has become easy. Okay na? Now let us go for dark bands. Dark band ఎంత అవుతుంది? Same thing. What is the nth formula? 2n minus 1 into lambda by 2 అంతే కదా? Put the value 1. Lambda by 2. 2. 3 lambda by 2. So substitute here. If n is equal to 1, what happened? First dark వస్తుంది అంటే ఎంత అవుతుంది మనకి వాల్యూ? ఫస్ట్ డార్క్. What is the path reference here? Lambda by 2, 3 lambda by 2, 5 lambda by 2, so on and so forth. So first one ఎంత అవుతుంది మీకు? d sin theta is equal to what? Lambda by 2 path reference కదా అంటే ఎంత అవుతుంది? sin theta lambda by 2d. ఓకేనా? సో lambda by 2d is equal to what? Your sin theta కదా. Now what is tan theta? Again equal to y by d. So lambda d by ఇక్కడ సబ్స్టిట్యూట్ చేసుకోవచ్చు మనం. lambda d by 2d ఫస్ట్ డార్క్, lambda d by 2d ఫస్ట్ డార్క్. కానీ ఇప్పుడు ఏంటి, షిఫ్ట్ అయిపోయింది ఇంత ప్లేస్లో. అప్పుడు ఏమవుతుంది? Now this is not lambda d by d. Lambda d by 2d plus td into mu minus 1 by d. This is the first dark. అలాగే సెకండ్ డార్క్ ఎంత అవుతుంది? 3 lambda d by 2d plus td into mu minus 1 by d. అలాగే థర్డ్ డార్క్ 3 to the 6 minus 1 5 వస్తుంది. So third dark is shifted to 5 lambda d by 2d plus td into mu minus 1 by d. అలాగే nth dark, please, nth dark 2n minus 1 into lambda by 2d plus td into mu minus 1 by d. nth dark ఎంత వస్తుంది? nth dark చూడండి, ఈ ప్లేస్లో ఏం పెడతారు? 2n minus 1 into lambda by 2 పెట్టండి. If you put 1, how much will get? Lambda by 2d. Lambda d వస్తుంది, lambda d. ఓకేనా? nth dark 2n minus 1 into lambda d by d. ఇదిగోండి థర్డ్ది 3 lambda d by 2d. ఓకేనా? ఇక్కడ వాల్యూ n ప్లేస్లో పెట్టండి. n ప్లేస్లో 1 పెడితే ఫస్ట్ వస్తుంది. n ప్లేస్లో 1 పెడితే ఫస్ట్ వస్తుంది. lambda by 8 చూడండి ఎంత వచ్చింది వాల్యూ? lambda d by 2d అంటే 2n minus 1 into lambda d capital D by 2dలో ఇది వస్తుంది టోటల్ వాల్యూ. దిస్ ఈజ్ వెరీ వెరీ ఇంపార్టెంట్ ప్లీజ్. ఇది nth డార్క్ ఫామ్ అవుతుంది. అంటే ఎందుకు మనకి షిఫ్ట్ అయిపోయింది. ఎంత డిస్టెన్స్? t ఇంటూ mu minus అంటే td ఇంటూ mu minus 1 by d షిఫ్ట్ అయిపోయింది సెంట్రల్ బ్యాండ్. సో ఎవ్రీథింగ్ యూ టు యాడ్ అప్ దట్ వాల్యూ ఫర్ బ్రైట్ అండ్ డార్క్. బ్రైట్కి వచ్చిన n lambda d by d, దీనికి 2n minus 1 into lambda d by 2d. ఇక్కడ 1 పెడితే ఎంత అయింది? n 1 పెట్టండి, lambda d by 2d. lambda d by 2d. 2 పెట్టండి, 4 minus 1 3 lambda d by 2d. 3 lambda d by 2d. Put 4 to the 8 minus 7 lambda d by 2d plus this thing td into mu minus 1 by d. So like this you have to calculate the values for bright and dark bands. Please be careful These are very, very important. You should not confuse. Okay? Clear? Have you checked up the formula? Right. So this is how the shifting is done for the due to the obstruction of the glass slab. Clear? So finally dark bands to bright bands మనకు వచ్చే 2n minus 1 into lambda d by 2d plus td into mu minus 1 by d. అలాగే అది lambda d n lambda d by d plus t into mu td into mu minus 1 by d. Okay? So like that we are calculating. Now we will go for the next one. That is, how many fringes are shifted? See here, because of this glass slab. Next one, how many fringes, bands, how many fringes are shifted due to the glass slab? సో ఇక్కడ మనం ఏం చేసాం, గ్లాస్ స్లాబ్ పెట్టాం స్లిట్ S1 దగ్గర. సో దానివల్ల ఎన్ని ఫ్రింజెస్ షిఫ్ట్ అయిపోయాయి, హౌ మనీ? ఓకే, దట్ విల్ క్యాల్కులేట్. ఆల్రెడీ యూ నో వాట్ ఈస్ ఫ్రింజ్ విత్ వాల్యూ, lambda d by d between any two consecutive dark bands or bright bands. So how many fringes అంటే ముందు యాక్చువల్లీ ఎంత షిఫ్ట్ అయిపోయింది మనకి చూడండి ఫార్ములా, td ఇంటూ చూడండి షిఫ్టింగ్ మనకి ఎలా జరిగింది, td ఇంటూ mu minus 1 by d కదా. సెంట్రల్ బ్యాండ్ నుంచి మనకి y ఎంత వచ్చింది, y we got y as td into mu minus 1 by d. This is the shifting. So how many fringes shifted means how much it has shifted by the fringe width value, by the fringe width d d. Okay na? Alage capital D, capital D. So finally you are left over t into mu minus 1 by lambda. That is the formula. Thickness of the slab into refractive index minus 1 by lambda. That many fringes have shifted up due to the introduction of the glass slab between any of the slit, either S1 or S2. T into mu minus 1 by lambda, where T is thickness of the slab, mu refractive index of the given slab, it will be given, lambda the wavelength. So that many fringes, bands has shifted up onto the top or bottom depending upon the given. Clear? Okay? So all of you following, see this chapter is little confusing, but you have to understand in a ప్రాపర్గా మనం అర్థం చేసుకుంటే కాన్సెప్ట్ని ఈ ప్రాబ్లమ్స్ చాలా బాగా చేయొచ్చు ఎగ్జామినేషన్లో. బట్టి పెట్టకండి, బికాస్ దిస్ చాప్టర్ మోస్ట్ ఆఫ్ ద పీపుల్ ఐఎమ్ సీయింగ్ దే ఆర్ మగింగ్ అప్. డోంట్ మగ్ అప్, నో ద కాన్సెప్ట్, సబ్జెక్ట్ విల్ బికమ్ వెరీ ఈజీ. అండ్ వన్ మోర్ విల్ బి గో ఫర్ దిస్ వన్, లాస్ట్ వన్ I think for today. We'll do one more problem. Let us try that one. Right. So last one for today we'll see, that is, for example, see here, I'll rub the entire figure, I'll draw again. Till now we are observing only single glass slab. Till now we are observing only a single glass slab. Ala kaakunda, for example, suppose this is slit 1, slit 2 distance is d, this is center 1 and this is screen. This is central 1. Okay? For example, ఇప్పుడు రెండు తీసుకున్నాను గ్లాస్ స్లాబ్స్. Now this is the wave 1 P. See, geometrically here S1P is equal to S2P, please, from geometry. But what I will do is, I will put two slabs, here one, here one. So two slabs, two glass slabs are kept, okay, at S1 and S2 slits. Now what happens? See, so you can geometrically S1P is equal to S2P, but because of this one, for example, the refractive index mu1, thickness T1, mu2, thickness T2. Now how much extra distance this one wave has to travel? S1p plus T into mu minus 1, that is T1 into mu1 minus 1. This way, ఈ wave ఎంత travel అవ్వాలి? S2p plus T2 into mu2 minus 1. So this has to travel this much extra distance, already I have derived T into mu minus 1. Now to become delta x is equal to 0 here, what should happen? This minus this should be equal to 0 ante S1p plus T1 into mu1 minus 1 minus S2p plus T2 into mu2 minus 1 should be equal to 0. And as you know, geometrically S1p is equal to S2p. అప్పుడు ఏమవుతుంది? See here, T1 into mu1 minus 1 minus T2 into mu2 minus 1 is equal to 0, or T1 into mu1 minus 1 is equal to T2 into mu2 minus 1. This is the formula, very very important in solving numericals. This is little advanced level. Ante to get again central band here, then what should happen? T1 into mu1 minus 1 should be equal to T2 into mu2 minus 1. Then only here delta x will be 0. Okay? In such cases only delta x, central band, will be formed here only. It won't form that side or this side. Clear? So this is how you have to understand the subject. Again we are left over with only diffraction experiment. Very easy one. Diffraction is left over, and after that we are left over. Diffraction లో మళ్ళీ మనకి బ్రైట్ డార్క్ వస్తాయి, కాకపోతే చాలా జాగ్రత్తగా ఉండాలి. ఇంత ముందు వచ్చినట్టుగా మనకి బ్రైట్ బ్యాండ్ డార్క్ రావచ్చు, ఇక్కడ డార్క్ వాల్యూలో బ్రైట్ రావచ్చు. See, in before cases we have seen in bright band as lambda, 2 lambda, 3 lambda, 4 lambda, n lambda. Dark bands we got as lambda by 2, 3 lambda by 2, 5 lambda, 2n minus 1 into lambda by 2. But in diffraction pattern it will be changing. In diffraction pattern it may change. Where you got bright before, you may get dark now. Where you got dark before, you may get bright. Okay? So before stopping that, I'll just give an introduction of diffraction and then I'll stop, and we'll cover in the third part of the wave optics. Okay na? Right. Just I'll give the introduction of diffraction. And then we'll go to the next part. This chapter is little easier than the ray optics because that is a very lengthy one. This is a little shorter. The second part of the wave optics, that is diffraction. So diffraction phenomenon also is observed in sound also. That means sound waves will totally bend after meeting any obstacle. Same thing again will be observed in light waves. So what is diffraction? Diffraction is total bending of the light rays. Total bending of the light rays after meeting any opaque body or obstacle. Opaque body or obstacle. Point అర్థమవుతుంది మీకు? For example, this is the source of light, suppose say, point source, like torch light. This is a point source of light. For example, light is coming in different directions. Okay? Suppose this light is coming in this direction. Suppose you have kept a small opaque body here. This is opaque body, any opaque body, where light does not enter inside. Like a wall, okay? Or any enclosure like wall, opaque body. Opaque means ఏంటి తెలుసు కదా, lower class చదివి ఉంటారు. Light cannot enter through it. So this is opaque body, like say AB, and here I have kept a screen. Here I kept a screen. Now suppose you can see total bending of light rays after meeting any opaque body and అర్థం ఏంటి? We all know old theory saying the light travels in a straight line. So if that is the case, when light is transferred to the opaque body, what should happen here? It should go straight. Light should go straight like this. And this entire part should be dark because obstruction is there. ఇక్కడ అడ్డు పెట్టాం కాబట్టి ఈ కింద మొత్తం అంతా బ్లాక్ అయిపోరు, డార్క్ ఉండాలి. అలా జరగదు. From the phenomena, what happens? Light after meeting obstacle, it bends away and encroaches in the shadow region. So this is shadow region. This is shadow part. So here light is entering. It goes in the end. A portion వచ్చినట్టు light will bend in this one. At the corners, if you see, suppose a small hole is there. If you put a torch light, ఆ హోల్ సైజ్ మీకు అవతల పక్క స్క్రీన్ మీద పడదు, కొంచెం హోల్ సైజ్ పెరుగుతుంది. బికాజ్ వాట్ హ్యాపెన్ ఆఫ్టర్ లైట్ గోయింగ్ ఇన్ టు దట్ హోల్ ఇట్ బెండ్స్ అవే అగైన్. దట్ ఈస్ వై లైట్ ఈస్ అ వేవ్ నేచర్, ఇట్ ఈస్ నాట్ అ స్ట్రైట్ లైన్. దట్ ఎక్స్పెరిమెంట్ ఈస్ ప్రూవింగ్ దట్ light is not a straight line, going in a wave nature. When you put a torchlight to a small hole in a cardboard, that hole size will be increased on the screen, and continuous pattern of dark bright bands are formed. Same thing is observed in this experiment. When a point source of light like a torchlight is kept on any opaque body like a wall, you can see light after meeting this point, it bends away into the shadow region, and above this one you can observe small bright bands, dark bands are fading out. మీరు అబ్జర్వ్ చేసినట్టయితే ఈ పై భాగంలో see, you can see bands are formed bright, dark, bright, dark, bright, dark, bright, dark, bright. So these are called as dark bands. చూడండి, dark bands ఇవి, ఈ మధ్యలో బ్రైట్, అండ్ యూ కెన్ అబ్జర్వ్ ఇట్ ఈస్ ఫేడ్ అయిపోతుంది, అంటే తగ్గిపోతుంది, లెంత్ విడ్త్ తగ్గిపోతుంది. అండ్ దిస్ ఈజ్ ఇల్యూమినేటెడ్ పార్ట్, దిస్ ఈజ్ కంప్లీట్లీ లైట్ పార్ట్. Are you following the point here? So from this experiment it is proved that light is wave nature, not particle nature. That is why Newton's theory has failed. Light does not travel in a straight line. Just do an experiment at your house. Put a torchlight, make a small hole in the cardboard and focus. Put any other screen outside on the wall. Put as a screen as a wall or any other big size cardboard you put it. Now whatever hole you have drilled in the cardboard, that hole size is increased little because of light after entering to that hole, it bends like this. Here you can see it bends away. That proves that light is wave nature. The size is increased and holes, dark bands చిన్న పట్టి లాగా ఫామ్ అవుతాయి, అవే డైఫ్రాక్షన్ ఫ్రింజెస్ అంటారు. Those are called as diffraction. So in other words, when a light rays meets an opaque body, light bends after meeting the obstacle and encroaches into the shadow region. Encroach అంటే అర్థం ఏంటి? Enters into the shadow region. That phenomenon is called as diffraction of light. Light అంటే సింపుల్గా చెప్పాలంటే టోటల్ బెండింగ్ ఆఫ్ ద లైట్ రేస్ ఆఫ్టర్ మీటింగ్ ద obstacle is called as diffraction. Or when light rays meets an obstacle, it encroaches the shadow region. That means after meeting the opaque body, it bends. స్ట్రైట్గా వెళ్ళదు, బెండ్ అయిపోతుంది, తగిలింది, బెండ్ అయిపోయి it will go in this fashion. And you can see this is the shadow region, and on the top you can see the diffraction bands. Dark, bright, the bands are fading out. And this portion is little illuminated portion. This is the first experiment you can understand regarding diffraction pattern. Okay? Same way you can go for a cardboard example also. Cardboard example. Same thing you can go for cardboards here. Cardboard example కూడా మీరు చూడవచ్చు. చూడండి, ఫర్ ఎగ్జాంపుల్ పాయింట్ సోర్స్ ఆఫ్ లైట్ Suppose one cardboard is kept like this. Small hole is drilled. Okay. Suppose here one more screen is kept. Now if you observe, actually ఈ size రావాలి మీకు. హోల్ ఇక్కడ రాదు. కొంచెం ఈ విధంగా వస్తుంది మీకు. వచ్చి the size will be little increasing. And not only this one, bright dark. Okay, you can see like this. Such type of bands you can see here. The whole size is increased because when light enters, what happens? Put a torch light. When light is entering, only this size has to form here. Because light is a bending nature. After meeting the obstacle due to diffraction, it bends away from the corners. Corners తగిలితే లైట్ బెండ్ అయిపోతుంది. ఇలా వెళ్తుంది చూడండి, ఇలా వెళ్ళిపోతుంది. సో అందుకే సైజు పెరిగి ఈ విధంగా డార్క్ బ్రైట్, డార్క్ బ్రైట్, డార్క్ బ్రైట్, డార్క్ బ్రైట్. So like this, diffraction patterns are formed from this experiment. This is a simple cardboard experiment you can perform at your home or in laboratory. Take 2 cardboards, one you make a small hole, point source of light, torch light, focus it, you can observe these patterns. So this is another experiment. Okay. So like this you can explain the diffraction phenomenon, and in next concept I will try to explain detailedly by taking a single slit. Before in YDSC you have taken 2 slits, S1 and S2, 2 slits, chinna holes. But in next experiment what I will do is single slit. And for example, take a cardboard and cut with a blade, just like it, one line. That is called a slit. So in such cases what happens? Only 1 or 2 sources won't come from the thing. Lakhs of sources, crores of sources of light will be coming from the slit. అంటే ఇలాంటి కార్డ్బోర్డ్ తీసుకొని, if I take a cardboard like this and if I make a small cut like this, small cut with blade, so from that what happens? Lakhs of light rays will be coming. So in such cases, what will be the diffraction pattern? What are the formulas for bright bands, dark bands? We'll be seeing in the next video, that is part 3 of wave optics. Until then, please study well and observe the derivations what I have done and do the numericals also. Okay.